Welcome to Vision Plus. My name is Chemist, and we are still looking at organic chemistry. We have gone far to polymerization. We need to see what is polymerization in detail, and after that, we shall be in position to at least synthesize some of the products through the process of polymerization. We have talked about detergents, and we have seen how detergents can be prepared also. And because of that, we shall now go further and look at polymerization. And when we say poly in chemistry or in other science subject, we are meaning that many or several. And when we say mono, we are meaning one. So polymerization is simply the chemical process that combines many monomers to form polymers. And we have these polymers, or a polymer is a compound formed by the combination of two or more molecules, and those molecules are what we call the monomers. Now, we have polymers and fibers, but a fiber, the only difference is that a fiber is a polymer which do not stretch easily, but we are just meaning the same thing. So the polymers and fibers, they can be classified in the two categories, and here we say we have the natural polymers and the natural polymers and fibers. Then we have the artificial, synthetics, or the man-made polymers and fibers. So these other ones, they occur natural. Yes, they are not made by man. And when we look at it critically, we are saying in part A, the natural polymers are polymers that are formed in nature. You get them in nature. Example is the starch. Now, why are we saying starch is a polymer? Starch is a polymer because it has monomers such as, so here are the monomers found in the starch. Monomers found in the starch. We have the glucose unit, mainly the alpha glucose. So then we have the cellulose, also the glucose units are the what? Are the monomers. So that means when I combine this glucose plus another glucose plus another glucose and I form that chain, could be straight chains or branch chains, we shall be in position to get what we call the starch. And it is called a polymer. Why? Because it is formed by, from glucose units, very many of them combining together. So therefore, cellulose and starch, they are polymers of glucose units. But when you go further, you see that starch are for alpha glucose, then cellulose is that one of beta glucose. So let's go to proteins. What are the monomers in proteins? We have ever heard of something we call amino acids. So when these amino acids combine, very many of them, we shall be in position to get proteins. So that process alone is what we call polymerization. Then we have glycogen is also from glucose units. Then we have the natural rubber. Now the natural rubber here, we shall be in position to get, that's a small units repeatedly of this rubber. They combine together to form this, what we call the natural rubber. We shall be in position to see how artificial rubber can be manufactured, and we shall see those respective monomers ahead of us. Then we have also what we call artificial polymers and fibers. Now these artificial ones, they are man-made. An example is the polythenes, and we have polychloroethane, sometimes we call it PBC. So when you say polyethylene, so that means the monomers here are the ethene molecules. Then here we have chloroethane B being the what? The monomers. And when we look at nylon also, we shall see the monomers there when we're going to manufacture nylon. We have nylon 6,6, And then we have phosphates. We shall also see the monomers, then synthetic rubber. So polymers and fibers are formed by a process called polymerization. So that's one thing we need to know, that this polymerization is the one that can bring about polymers and fibers. And the only difference between polymers and fibers is that for fibers, they do not stretch easily. So we have two types of this very process. The process which we say it results into the formation of polymers through the combination of these monomers. So there are also different types of monomers, and because of that difference, we also came up with a different type of polymerization. And we say we have something called the addition polymerization. Some students will rush and say additional polymerization, but there is no AL added here. It is addition polymerization. Then we have condensation polymerization. So when we look at this thing critically, we are saying for addition polymerization, this type of polymerization will result from the formation of polymers from unsaturated. So when we say it, in our introductory part of organic chemistry, we talk about hydrocarbons. And we say we have saturated hydrocarbons and we have unsaturated hydrocarbons. So when we say unsaturated hydrocarbons, those were the ones that we say they have either double bonds or triple bonds. But when we say something is saturated, that means it is having single bond between at least between these carbon atoms. But for unsaturated, we have doubles or single bond between at least two carbon atoms in that very chain. So this type of polymerization results from the formation of these large molecules, and they're being built up from these unsaturated monomers to form a single product. Why are we saying the single product? Because what is being formed is that we are not seeing like a kind of another product being formed. But when we're going to look at condensation ahead of us, we're going to see that for condensation polymerizations, here we shall form the polymers from saturated monomers, and in the process there are some molecules which can be given out or forming a process like water, like ammonia gas, and some others. So that's the difference between addition polymerization and condensation polymerization. And we have also examples, and we say, what if I have ethene, this one here, and I repeat many of them? This end we are just saying there are several of them being repeated, the molecules being repeated in presence of high temperature and high pressure. We shall be in position to form what we call polyethylene. And this polyethylene best example is the polyethylene bag that we normally use, or we call kevlar. This one here is just formed by the process called addition polymerization. And this is what we call the polyethylene bag. So, and then here we shall see that when we combine a small unit of what we call the chloroethane at this temperature 60 degrees Celsius and high pressure, and we had this catalyst called hydrogen peroxide, we shall be in position to get what we call fluorochloroethane. Now what is happening up this double bond breaks down and we form something like this. Now after it breaking, that means it allows this formation of the polymer. So many of them will just be in that format. And you see that this N represent those number of monomers. Then when we look at this one down, they say this monomer is called phenylethene. Now this phenylethene can also form a polymer called phenylethene. And then it is in the presence of the catalyst and heat. So where you are seeing they are not specific with the amount of pressure needed, the amount of all the catalyst needed to put it in that format. So this is exactly what polymerization is all about. And we're going to see how it can come up with heavy equations to at least drive or form very many polymers and fibers in the process of what we call polymerization. So here, what you need to be keen enough on is that you have to make sure that these bonds are shown clearly. And then here they are breaking and your end must not miss. So maybe they can write for you the equation like that and they will tell you in exam to state the condition. So here you say high temperature and high pressure. Then maybe they will tell you to name the what? This monomer, you'll be in position to say it is called ethene. Then if they tell you to name this polymer, you'll be in position to say it is called polyethenes. And in the process, you have passed the exam very well. So this is all about polymerization, but also we shall see more examples ahead of us.